In this video, you'll learn how to use Caddy as a web load balancer. We will be using 3 servers. The first server, called LBO1, is going to act as the load balancer. The other 2 servers are going to act as the web servers. They are named Web01 and Web02. By the way, if you're familiar with Vagrant and want to follow along, you can download the Vagrant file below this video. Vagrant allows you to quickly create virtual machines which can act as local test and development environments. The Vagrant file attached to this video will create the 3 servers we'll be working with today. There's also a cheat sheet you can download that lists all the commands and configurations used in this video. Here's a diagram that shows what we're going to accomplish. We will be building a load balancer that will accept requests from clients, route those requests to a web server for processing, and send back the results to the client. If a web server isn't available or is down, the load balancer will send the request to a web server that is up and accepting connections, and it then sends the resulting response back to the client. In short, a load balancer distributes incoming network traffic across multiple servers, ensuring that no single server is overloaded, and also ensuring that each client gets a response from a server to handle their request. By the way, you'll often hear the server components of this architecture called back-end servers. You may also hear the back-end servers called upstreams, as in the Caddy documentation. There are several load balancing options or load balancing policies for Caddy. The first is random. This algorithm selects a back-end or upstream server randomly for each incoming request. When all the back-end servers have the same specifications, this should distribute traffic fairly evenly, or at least in theory it should. If you use Caddy for load balancing but do not specify a load balancing policy, it will use random as it's the default load balancing policy for Caddy. Another Caddy load balancing policy is round robin, and it ensures requests to the backend servers are distributed in a round robin fashion. If you have 2 web servers like we do in this case, the first request will go to the first web server, the second request will go to the second web server, the third request will go back to the first web server, and so on. The next option is least_con, or least connected. This algorithm sends each new request to the backend server with the least number of active connections. When the processing power and specifications of the backend servers vary, this policy can be useful as it can help balance the workload more evenly. The next load balancing policy we are going to cover is called IP_hash. This policy tells Caddy to use a hash function to determine what server should be selected for a request based on the client's IP address. This means that all requests from a given IP address will be routed to the same backend server and thus makes users' sessions sticky. Subsequent requests from a specific IP address will always be routed to the same backend server. This can be useful for applications that require session persistence. On the other hand, if you are using a round-robin or least connected load balancing policy, a particular client's request will not be tied to a particular backend server. The final load balancing policy we are going to cover is first. This policy selects the first available backend server from a list of defined backend servers, starting with the first one listed in the configuration, then proceeding down the list until an available backend server processes the request. This policy can be useful in situations where you want to prioritize certain backend servers over others, such as when you have a primary backend server that you want to direct traffic to before any secondary or backup servers. There are other policies such as URI hash, header, and cookie, and you can explore those lesser used options on your own if you wish. I'm going to create a directory here on my local system to store my Vagrant configuration. The only thing that Vagrant allows me to do is quickly spin up some virtual machines that I can use to demonstrate this Caddy load balancing with. Of course, you don't have to use Vagrant. You can use just regular VMs that you manually provision. You can use the cloud. You can use physical hardware or whatever suits you. To bring up the machines, I just simply need to run Vagrant up. By the way, it's important to note that for this demonstration, I'm using Ubuntu 22.04. Okay, great. Vagrant has created 3 virtual machines for us, and they're currently running. So I'm going to open up a one terminal tab for each one of these virtual machines and connect to them. Since I'm using Vagrant, I can use Vagrant SSH, But of course, you just connect to your Linux servers the way you normally do. I'm going to go back to my first tab in my first virtual machine of Web 01. So now let's go ahead and install the web server. You could use Apache, Nginx, Lydie, Caddy, or whatever. This could also be a Node.js application, a Ruby on Rails app, a Python Flask app, or something else entirely. Since we'll be using Caddy for the load balancer, I'll go ahead and use Caddy for the web server as well. I'm going to cheat a little bit and I'm just going to copy and paste this command here in my terminal. Now, this might look like a long and scary command, but in essence, what it does is securely adds the GPG key for the Caddy stable repository to your system's trusted key rings. Now, this is a crucial step in securely setting up a third-party repository on a Debian or Ubuntu system, as it allows the package manager, apt, to verify the authenticity and integrity of packages downloaded from this repository. Again, to avoid typing mistakes, I'm just going to copy and paste this next command in my terminal as well. Now, what this command does is downloads the repository information for the Caddy stable software repository and adds it to the apt sources list under etc apt sources.list.d. Now, this allows apt to check this new repository for software packages, which is useful when you want to install or update the Caddy web server using the apt command. Now that we've added the Caddy repository to our list of available package sources, let's tell the system to refresh the list of available packages. Now we can install Caddy. Let's quickly see if it's running. By the way, you might be familiar with another command that acts in an almost identical fashion to ss, and that command is netstat. At this point, netstat is considered a legacy command and is being replaced in favor of the ss command. So if you're on an older distro, you can run netstat-ntlp, or on the latest distros, you can run ss-ntlp. In any case, we can see right here that Caddy is listening on port 80, which is the default port for HTTP traffic. By default, the document root is in user share Caddy, and I'm going to replace the contents of the index.html file in that directory with the name of the server. The uname-n command gives us the host name of the server, and the sudo t command puts the output of the uname command into the user share Caddy index.html file. The cat command displays the contents of a file. Now, by the way, the exclamation mark followed by a $sign gets replaced with the last item from the previous command, and I find myself using this shortcut a lot. Anyway, let's make a request to the web server. All right, it returns web01, which is the contents of that index.html file. Now, when we make a connection through the load balancer, we'll be able to tell what backend server we're hitting. Let's go ahead and perform the same steps on Web02. I'm going to move over here to my next tab where I'm connected to Web02, and I'm going to use the same commands to install Caddy. Again, we're going to place the host name into the index.html file, and we'll make sure it responds with its own name. And it does. Okay, let's move over to our final tab, which is on the load balancer, and we're going to install Caddy there as well. Now here on the load balancer, I'm going to edit the configuration file, which is etc caddy file. One of the things that I love about Caddy is that its configuration can be very simple. It can do a lot with very little configuration because of its well-chosen default settings. This simple configuration says accept all incoming requests on port 80 and forward them or proxy them to either 192.168.56.51 or 192.168.56.52. Note that we didn't specify a load balancing policy. This means Caddy will use the random load balancing policy. And now that we do have our new configuration in place, let's reload Caddy so it rereads that configuration. Let's see what happens when we start making requests to the load balancer. First, we get a response from the Web01 backend. And now Web02, Web01, Web02, Web01, Web01, Web02. So there you can see that we got Web01 a couple times in a row. And again, the default policy here is random, so it's randomly choosing between our backend servers. And of course, we only have two. In a larger configuration or larger setting, you'll see more variants. Of course, clients will actually be hitting the public-facing IP address of the load balancer, so let's demonstrate that as well. Again, our load balancer IP is .50, Web01 is .51, and Web02 is .52. So here's what it would look like if you were coming from the outside and hitting this public IP address, or the public-facing IP address, I should say, of the load balancer. Again, here we're getting some random results. A few times we went to Web02 and then we went to Web01. Now, this default random policy may very well be all you need when implementing a load balancer. With Caddy and one simple line of configuration, your job might just be done. But let's say you want to use a round robin policy. Now, what would that look like? Well, first let me make a backup of the current configuration. Now let's edit our configuration. So what I've done here is added a stanza for the reverse proxy directive. And in that stanza, we'll tell it to use the LB policy, or load balancing policy, of round robin. Again, this is a very simple configuration, and it makes Caddy such a pleasure to use. Now let's tell Caddy to reread its configuration. Okay, now let's see what happens when we start sending requests to the load balancer. As you can see, the load balancer is sending one request to one backend server, the next request to the next server in the list, and so on. So the round robin policy is working as expected. Let's back up this configuration and try yet another load balancing policy. Okay, let's change from round robin to IP hash. Remember, we have to tell Caddy to reread its configuration. Okay, let's get back to making requests to the load balancer. Now, in this example, the load balancer has routed our request to Web02. Because we're using the IP hash policy, all of our future requests from this IP address will be routed to the same backend server. So no matter how many times I run a request to this server, I'm going to be directed to the Web02 backend. So if you need to tie a particular session with one backend server, then use the IP hash load balancing policy. By the way, another great thing about Caddy is that it can automatically handle the registration and renewal of SSL certificates for free. You can use Caddy as a load balancer and SSL terminator, and I'll save that for another video. In this lesson, you learned how to use Caddy as a web load balancer to distribute incoming network traffic across multiple servers, what the most commonly used load balancing policies are for Caddy, why and when to use each of the policies, and finally, how to implement each load balancing policy. If you want a copy of all the commands and configurations used in this video, be sure to download the files below.